Hello class. Today we are going to be discussing graphing quadratic equations. Quadratic equations have a lot of applications, and this is just one of them. We have our Angry Bird game. You can see that the path of the bird follows a parabola, and you can tell whether that particular bird will hit a pig by looking at the intercepts of the parabola. So here this x-intercept misses that pig, so bummer. So today we're going to talk about graphing these quadratic equations. We're going to be focusing today on two particular forms of quadratic equations. You know from a previous lesson that we can solve quadratic equations in different forms, whether they're factored or whether they are in standard form, where you'll use the quadratic formula, or perhaps you'll use completing the square. The different forms of quadratic equations that mirror this in graphing, one is called intercept form. Intercept form is also called factored form because you factor to get it into that form. And the intercept form is some constant a times x minus p times x minus q, where p and q are the intercepts. So you know that if you solve for x here, the two intercepts will be p and q. So if you have an equation in factored form, it's fairly straightforward to graph that parabola. However, not all equations are factorable, so you can't get all equations into intercept form. And just as a note to you, P and Q might be listed as different letters. So they could use X1 and X2. I've seen various letters used there, but P and Q are just fine for naming the intercepts as well. Next, we have our vertex form. The vertex form is very useful in graphing because it tells you exactly where the intercept is. So you can determine what the intercept is, or I'm sorry, the vertex is. The vertex would be at h comma k, and then looking at the a value can tell you whether the parabola is upward, downward, wide, or narrow. So vertex form gives you a nice sketch of a parabola, and most parabolas are given in standard form. So that's just the y equals ax squared plus bx plus c. So standard form is what it kind of comes in. It's not as useful for graphing in that form. So we're going to talk about how to get equations out of standard form and into one of these other more useful graphing forms. And we're also going to talk about how we can use standard form to graph just from that form. So we're going to be able to graph from all three forms, but some forms are more useful than others. So graphing quadratics in intercept form means that we can take an equation, a quadratic equation, we can factor it, and therefore it will be in intercept form, and then we can graph that particular quadratic. So here's a quadratic equation, and this is the same quadratic equation. We could represent the same relationship by factoring. So the factored form of this equation is x plus 3 times x minus 1. And since we are doing a form of an equation, we can write y equals for that. So y equals x plus 3 times x minus 1 would be the factorization of that quadratic. So now you have that particular equation in intercept form. Now, looking at the equation in intercept form, we can notice right away that these x-intercepts show up on our graph. So we look at this particular form, and we can see that the solutions to this equation, when the right side is 0, right here, if the right side is 0, the solutions are x equals 1 and x equals 3, negative 3. So when we go to look at the graph, we know that those are the intercepts of the graph. So x equals 1 is the intercept right here. X equals -3 is the intercept right there. So those intercepts are very useful in graphing. However, they don't tell us where the vertex is. So while intercept form helps us, oh, there it went. Sorry. While the intercept form tells us where the graph will intersect the x-axis, it doesn't tell us where the vertex is. The vertex could be anywhere in between these two values. So where does it hit the x-axis? We already found that. Those are the x-intercepts. Where is it lowest? So let's go back. The lowest value is right here. So it's lowest at the point -1, -4. So it hits the x-axis at -3 and 1. It's at its lowest point at x equals -1. And if I want to know how these are related, well, let's take a look at the graph now again. If I look at the graph, I have this intercept, which occurs right here. Let me just use a pen here. This intercept, which occurs right there. This intercept, which occurs right here. And then the lowest point, which we call the vertex, which occurs right here. I'd like you to note that the vertex occurs halfway in between the two x-intercepts. So this line that I can draw that cuts the parabola into two equal parts is called the line of symmetry. And the point that is present on the line of symmetry is the vertex. So if you can find the halfway point between the x-intercepts, you have found the x value of the vertex. And that is incredibly useful in writing the equation of the line. So we can then say that the vertex occurs halfway between the two x-intercepts. And we're talking about the x values. So I could simply take these 2 points, add them together. I get -2, divide by 2, and I get -1. So I can find the halfway point by taking the average of these two values. If they are strange numbers in particular, that is useful. So this is a key concept. Okay, so for example, let's sketch the graph of y equals x plus 4 times x plus 2. So the first thing we're going to do is identify the intercepts. So the intercepts occur when y equals 0. So y equals 0 at x equals -4 and x equals -2. And I get those just by solving this equation. Now I can put those two solutions on my graph. So -4 and -2. So we know our parabola needs to go through these 2 points. Also, I can kind of picture, wow, I erased too much. I can kind of picture that my vertex will be somewhere in between here. Now, we know then that we can sketch the line of symmetry. The line of symmetry is that line that cuts the parabola perfectly in half. So that's my line of symmetry. my vertex occurs somewhere upon this line. So here's my vertex. So my vertex has to be somewhere on the line. I don't know exactly where. So I know the equation of this line is the midway point between -2 and -4. So that means my vertex is at an x value of -3, which also happens to be the line of symmetry of the parabola, which means the parabola's halfway marker is this line. So to find the corresponding y value of this, what we need to do is plug x equals -3 into our function. So I could write y equals -3 plus 4 times -3 plus 2. And when I do that math, I get that y equals 1 times -1, which is -1. So that means for an x value of -3, if I substitute that in, I get a y value of -1, which means my vertex is at -3, -1. Now, if I know my intercepts and I know my vertex, I can write a pretty accurate equation. So now I'm going to grab my pen and graph this. Another cool thing you can do is estimate the y-intercept or calculate the y-intercept in your head. The y-intercept occurs when x is 0. So if that is true, if the y-intercept is occurring when x is 0, so here are my intercepts, here is my vertex. If the y-intercept occurs when x is 0, I can quickly do a calculation that y equals 4 times 2 based on x being 0. So my y-intercept would be at 8. So when I drew my parabola here, I was going to try and eye it and go for that being at 8. And I could kind of fudge it here. Yeah, here it's 8. So you can get a pretty nice looking parabola because you have 1, 2, 3, 4 different points. And also, if you look here, do you see here's your line of symmetry? The y-intercept is 1, 2, 3 away. Your other point should be 1, 2, 3 away in this direction. So that gives you a more symmetrical parabola. So let me try that again. I can fix it. All right, not too shabby. It's a little hard to write using a mouse. So there's the parabola. So note my first step. My first step was finding the intercepts. My second step was finding the vertex. And the third step was noting the y-intercept. So in conclusion, intercepts, vertex, and then the y-intercept, because the y-intercept just gives us a little more information to draw a good graph. Intercepts, vertex, y-intercept. Let's do another one. So taking a look at this, I can first focus on my intercepts. So my intercepts are going to be at the roots of this equation. So what will make y equal to 0? So that's going to be x equaling -1 and x equaling 1. So here are my intercepts. Now, if we take a look at your vertex, that's really the next step. The vertex occurs halfway between your x and your y intercept. I'm sorry, your two x intercepts. So we have one intercept at -1, and I'm just going to throw that on the graph so I can see it, and one intercept at 1. And so drawing in, it's useful to draw in your line of symmetry. I'll choose green this time. So we can see our line of symmetry is going to cut right on top of the y-axis. So we have our intercepts at -1 and 1, and our line of symmetry at the point x equals, or at the line x equals 0. So wherever you have the line of symmetry, you have the vertex. So we know our vertex occurs at x equals 0. And then if we know our vertex occurs at x equals 0, we can find the corresponding y value by substituting in 0 for x. And so I found that the y value for my vertex is -2 times 1 times -1, which is a vertex of 2 for my y value. So I know then my vertex is at 0, 2, and I can place that on my graph. So you can probably tell by now we must have to have a downward parabola, and our a value is negative, so that supports it. So now that we've considered the vertex and the x-intercepts, unfortunately, our y-intercept, we already know. It happens to also be our vertex. So one thing you may want to do is pick a couple of other points, maybe at x equals 2 and x equals -2, just so you can get a sense of the width of the parabola. So I'll have you guys do that in your own time, because I know you all can plug and chug. But this is going to be a thinner parabola than your last one, because if this value is above 1, you know it's going to be a narrower parabola, and if it's negative, it's an upside down parabola. So you can identify the vertex and the x-intercepts and just check to make sure this a value mirrors what you see in your graph. So you see a downward, because it's negative, narrow, because it's 2 parabola. Okay, now if we take a look at this one, we have x times x minus 9. If we're going to look at our x-intercepts, the x-intercepts occur when y is 0. So our x-intercepts are going to be 0 and 9, solving that factored equation. And if it's not factored, you just factor it yourself. So I'm going to put those 2 points on my graph at 0 and at 9. And so if I know my x-intercepts are at 0 and 9, I can find my line of symmetry by finding the line that's halfway in between. So to find the vertex, you need the halfway point. So one way to find the halfway point algebraically is just to take the average of those 2 points. So to take the average, you're just going to add them up, the 2 points. So 0 plus 9 is 9. And 9 divided by 2, because there are 2 points, is your average. So that means your x value of your vertex is 4.5. So I can put my line of symmetry on my graph at 1, 2, 3, 4.5 right here. And that should cut this particular line, or this segment, in half. So both of these points should be equidistant from your line of symmetry. So I have 1, 2, 3, 4.5 on this side, and 1, 2, 3, 4.5 on this side. And then I can label that my line of symmetry is just at x equals 4.5. And my vertex is somewhere along here. So to find my vertex, I'm going to plug 4.5 into my equation, or the y value of the vertex. So I get y equals 4.5 times 4.5 minus 9. And that, I'm getting out my calculator since I don't have you guys to help me out, is negative 20.25. Which makes my vertex at 4.5, comma, negative 20.25. So that is my vertex. And given that, you can put it on the graph. Now, I may want to scale my y-axis by 2s just so I can fit this on the graph. However, it's not generally suggested that you do that because the parabola is going to look more compact than it is in actuality. So if I go by 2s on my y, it's going to look wider than it is in actuality. So for the sake of, not having to make my graph huge, I'm just going to put it there and label it in 4.5, comma, negative 20.25. And do know that this parabola is really, if you take a line and just stretch it, it should be stretched by a factor of 2. And again, the y-intercept we know is 0, so it's not really going to help us to find that again. Okay, and this looks terrible, but everything else is good besides the actual shapiness of this. I just made up a word. Okay, so in summary, the graphs of quadratic equations are called parabolas. The vertex of a parabola is where it reaches its highest or lowest point, and parabolas are perfectly symmetric with the axis of reflection, also called the axis of symmetry, that goes through the vertex. And the way to graph equations that are in intercept form is first you want to find the y-intercepts by setting y equal to 0. And again, first you have to factor it. Let me add that. Oh, there's a random one there. Factor it. If it is factorable, you can do this. If it's not factorable, we need another plan, because this is all about graphing when it's in intercept or factored form. So find the x by setting y equal to 0 and solving for x. Find the x value of the vertex by finding the middle between the x-intercepts. And then find the y value of the vertex by plugging in the x value. So these are all things we did during our example. And then I'm going to also put to use the y-intercepts for a more accurate graph. So this is the steps. These are the steps we went through. Mrs. Zeidler is going to pass out a worksheet for you all to work on for the rest of the hour. Do know that you are expected to do this without the aid of a graphing calculator. If all you're doing is plugging in points into your calculator or plugging in a graph, you're not learning there. You're just pressing buttons. So I highly suggest you check your graphs on your calculators after you graph them by hand, but graph them by hand first. Also, you do not want to graph these by making a table. Okay, making a table is a skill any person in pre-algebra can do. You want to graph smarter by finding points that are important and that are key to the graph, and then making your drawing beyond that. All right, so we're trying to get away from having to create a table to graph. So this is one of the ways we can do that, and this particular method works for all factorable equations. So again, today we focused on graphing equations in intercept form. All right, guys, get ready for Jeopardy tomorrow. And Mrs. Zeidler, thank you, and thank you for passing out the homework.